Hello and Namaste. In continuation with the successive differentiation, after the complete introduction with the topic and the standard formally, we are going ahead with the different kind of problems. Now first, if y is equals to a times cos of log of x plus b times sine of log of x, then prove that x square y2 plus x times y1 plus y is equals to 0. Now this function has been given to us as y is equals to a times cos of log of x plus b times sine of log of x. Differentiating both the sides with respect to x, we will get it as y1 is equals to minus a sine cos sine, the cos differentiation of cos is minus sine log of x into differentiation of this log of x as 1 by x plus b into differentiation of sine is cos plus cos into log cos of log of x into 1 by x. Now taking this x to the other side, it will gives us x y1 is equals to minus a sine of log of x plus b times cos of log of x. Again differentiating both the sides with respect to x, we will get it as x y2, because see this is x into y1, so that means what, there is u into v rule will be applicable here in the LHS side. So x into differentiation of y1 is y2 plus the differentiation of x is 1, which is 1 into y1. So LHS is x y2 plus y1. RHS will happen, the differentiation of sine is plus cos, so minus a cos, minus is from here, minus a cos of log of x into 1 by x, again because of this differentiation of log of x with respect to x, minus, now we have got a cos in the previous step, so differentiation of cos is minus sine, so minus b sine of log of x into 1 by x. Again taking the x to the other side, we are going to get it x square y2 plus x times y1 is equals to minus a times cos of log of x minus b times sine of log of x. Now taking the minus sign out, we can say we can have it here a cos of log of x plus b times sine of log of x, and we'll observe here that this is nothing but the value of y. That means this is nothing but minus of y, and taking the y minus y to the other side, we are going to get it x square y2 plus x y1 plus y is equals to 0. This is what we wanted to find it out, or we wanted to show this particular question. It's a very simple using the differentiation of this particular thing. Now if y is equals to e to the power a sine inverse of x, then prove that 1 minus x square y2 minus x into y1 is equals to a square y. Now from this particular, you can understand that at least 2 times we have to differentiate this particular y so that we can reach to this particular type of prove that or reduction part. Now y is equals to e to the power a sine inverse of x, differentiating both the sides with respect to x, we are going to get it e to the power a sine inverse of x into differentiation of this a sine inverse of x, which is a into sine inverse of x, the differentiation is 1 upon square root of 1 minus x square. Taking this square root sign, that means y1 is equals to a into y. So because see, this e to the power a sine inverse of x is same as that of the function y given to us. So it is nothing but ay upon square root of 1 minus x square. Taking this square root of 1 minus x square to the other side, we are going to get it y1 square root of 1 minus x square is equals to ay. Squaring both the sides, we are going to get it y1 square into 1 minus x square is equals to a square y square. Differentiating with respect to x, we are going to get it. Now differentiating this LHS side would be 2 times y1 into, so 2 times y1 into differentiation of y1 is y2. So this is what is the differentiation of y2 has been given to you here. Y1 is given to you or y2 as into 1 minus x square as it is plus y1 square as it is into differentiation of 1 minus x square, that is minus of 2x, which is equals to a square 2y y1. So the same thing is happening here, it's 2 times, so it's 2y into differentiation of y, that is y1. Now rearranging the terms, here is nothing but 2y1, we have taken it out from both the sides, LHS side. We are getting it here as 1 minus x square y2 minus x times y1 is equals to 2y1 a square y. Now y1 will go up from here, 2 will also go up from here, you will remain here with the answer 1 minus x square y2 minus x times y1 is equals to a square y. That is what we wanted from this particular question. Moving towards the next is, if y is equals to sine of mx plus cos of mx, prove that yn is equals to m to the power n into 1 plus minus 1 to the power n sine of 2mx to the power 1 by 2. Now check this. To bring this 1 by 2, we have to arrange this term. Now, before moving ahead, let us go that y is equals to sin mx plus cos of mx. The nth derivative, we are aware of sin mx and cos of mx is nothing but, so we have got if sin of ax plus b, then a to the power n sin of ax plus b n pi by 2 and a to the power n cos of ax plus b n pi by 2. This is the differentiation or nth term of this particular sin and cos term. But here in this case, we have got the small a is small m because it's a constant in m, and b, the value of b is equals to 0 here in this case. So writing the nth derivative, we are going to get it m to the power n because we have got it. The value of a is nothing but m. So m to the power n sin of mx plus n pi by 2 plus m to the power n sin cos of mx plus n pi by 2. Now, just we have to have this arrangement. So m to the power n, we have taken it out from both the sides here, both the cases here, and please do check it here. It's nothing but dividing, or you can say taking the power as 2 by 2, that is 1 2 we are giving it here in the curly bracket, and 1 by 2 we are keeping it here aside because we wanted this into the picture here. So yn, this is an arrangement we are going to go ahead. Now it's a plus b the whole square. We are just expanding it, a square plus b square plus 2 times a b, that is sine square angle cos square angle plus 2 times sine angle into cos of the angle. This is raised to 1 by 2. This is about yn. Let us skip the same term just to have a reference. So this is the last term, last step we have got it in the previous slide. Yn is equals to this. Now if you observe, sin square theta plus cos square theta is going to give you 1, and 2 times sin theta into cos of theta is nothing but 2 times, this is nothing but here this we can have it here in the next time, sine of 2 times theta, that is mx plus n pi by 2. So this is what we have got it here in this particular step. Now after getting this particular step here, we have got it sine of a plus b. A plus b, we have just expanded that. So what is a here in the cases? A is 2mx and capital B is nothing but n pi, and that is what, if you observe here, sine of n pi is always coming out to be 0, and this cos of n pi is minus 1 to the power n, and that is what we are going to get it as this sine 2mx. So you can say m to the power n in bracket 1 plus minus 1 to the power n, that is of cos of n pi. We have written the value sine of 2mx as it is raised to 1 by 2. Why? Because the second term, this particular term is going to be 0 because of the existence of sine n pi in this particular case. This is what is the important question you can just understand here. The next question is find yn if y is equals to x to the power 4 upon x minus 1 into x minus 2. So as we are aware of, the degree of the numerator should be always strictly less than the degree of the denominator to have the partial fraction of this particular step. As we do not have that, we have the degree of the numerator is greater than the degree of the denominator. In the present case, we have to do the actual division. Now while doing the actual division, we have to that 1 x minus 1 x minus 2, we have to take it as x square minus 3x plus 2, and we are dividing this 2x to the power 4. Now this is a simple you can say a division, a long division. We have done it here, that is, this is what we have got the quotient as x square plus 3x plus 7, and this is the remainder as 15x minus 14. Rewriting this stuff as the quotient plus the remainder upon the integrand here, that is x square minus 3x plus 2. Here we are again getting back to x minus 1 into x minus 2, and then we are going ahead with the 15x minus 14 upon x minus 1 into x minus 2 as the hiding method. We are using here the hiding method to get the value of a and b. To get the value of a here, we need the value of x is equals to 1. So if x is equals to 1, then what will happen? We have to put x is equals to 1 here in the numerator. We cannot put it here, we have to put it here. So it is nothing but 15 minus 14 is 1 upon this is minus 1. So we got it as a is equals to minus of 1. To get the value of b, denominator is x minus 2. So we have to put, if x is equals to 2, then what will happen in that case? So putting this in the numerator, putting it here but not here in this bracket. That's the reason we are calling this as a hiding method. If we are putting x is equals to 2 everywhere, we are going to get the value of b is equals to this equals to 16. So we are getting the value of equals to 16 here, and therefore we got this particular value as y is equals to x square plus 3x plus 7 plus b is 16. So we are writing 16, that is plus sign here, 16 upon x minus 2 minus 1 upon x minus 1. So we got separated this particular y function. Now we know that yn, so if y is equals to 1 upon ax plus b, the nth derivative has been given to us as minus 1 to the power n, a to the power n, and factorial upon x plus b to the power n plus 1. Now in the present case, this here we have got the value of a equals to 1 in both the cases. So it's 1x minus 2, 1x minus 1. So that means what we are going to get it as 1 to the power n is equals to 1 everywhere in this both the cases. So therefore, okay, if we are taking the nth derivative, what will happen to this particular term? Will be 0, this will be 0, and this will also be 0, because we are going ahead with the nth derivative of this particular function. So this is 16 into minus 1 to the power n and factorial upon x minus 2 the bracket n plus 1 minus 1 to the power n factorial upon x minus 1 to the power n plus 1, using this particular, the formula of a standard formula here function. And we have got, taking this minus 1 to the power n and factorial out, we are going to get the yn as this 16 upon x minus 2 the bracket n plus 1 minus 1 upon x minus 1 to the power n plus 1 into minus 1 to the power n and factorial. So we got this particular function. The important step to note it down this as here, that is the degree of the numerator should be strictly less than the degree of the denominator. If they are equal or they are greater, we have to go for this actual division method once, get the remainder, write down the function in this way, and just try to go ahead with this, the way which we have done it in this case. So I'm trying to use the different combinations of the successive questions in a same particular box. Find yn if y is equals to x square upon x minus 1 the square into x plus 1. Now if you'll observe here, the degree of the numerator is 2, degree of the denominator is coming out to be 3. That means what, we can directly go ahead with the partial fraction. This is x square upon this x minus 1 the square, x plus 2, and this is abc, because we have taken it as x minus 1 the square as a upon x minus 1 plus b upon x minus 1 the whole square. So this is coming out to be, so if you observe here, so I am having these two brackets over here, so x minus 1 the whole square, x plus 2. So using the hiding method, you can get the value of b and you can get the value of c. We can't go for the value of a, we have to go first identify the value of b and c, and then we can go ahead the value of a. Now to get the value of b here, it is the numerator of x minus 1 the whole square. So if x is equals to 1, then what will happen? We have to put the x is equals to 1 in the numerator, not in the first bracket, but yes in the second bracket. That is coming out to be 1 upon 3. So we are going to get this b equals to 1 by 3. To get the value of c, we have to have if x is equals to minus 2. Now this x is equals to minus 2, you can put it in the numerator, you can put it here in the first bracket, but can't be in the second bracket. And this is minus 2, so it's a 4 upon, this is minus 2 plus 1, so minus 3 square is 9. So we are getting the value of c is equals to 4 by 9. So that means what, we have got this a, b, c, out of these 3 variables or 3 values, we have got the values of b and c. So it's a upon x minus 1 plus 1 by 3, x minus 1 the square plus 4 by 9, x plus 2. Now after getting these values, we can easily form this equation, cross multiplication and all, taking the LCM and all. A into, because we have got x minus 1 in the denominator here, so while taking the LCM, it is just x minus 1 once here into x plus 2. While taking this 1 by 3 into the denominator, we have x minus 1 the square, so we have to just take x plus 2. And while taking 4 by 9 here, so we have to take x minus 1 the whole square. Now taking this multiplication, why? Because we are interested only in the value of a, and we are aware of 1 by 3 and that is b, value of b and c. So that's the reason it's very simple for us to go ahead with the hiding method, go and get the value of b, go and get the value of c, and then take the values of these two values, and then go for the traditional way of taking the LCM, equating the equations and all. We can go ahead with a very fast way of doing this partial fraction. Now here we are interested only in a, we do not want any other variable, so we have to just acquire the variables where we can get the values. So if you'll observe here, this is ax squared 4 by 9 x squared. So we want to have we wanted to have only that much of variables or equations which we want to calculate the value for. So we are just trying to collect the values of this particular, the x squared, the coefficient of x squared. I've highlighted with the red color. So if you'll observe here, the value of this, so we are going to get it, 1 is equals to a plus 4 by 9. Now that means what? We are going to get this, this gives us the value of a is equals to 1 minus 4 by 9, which is equals to 5 by 9. So we got the value of this particular y, or you can say this particular function, which is given to us in the first question. It's 5 by 9 times 1 upon x minus 1 plus 1 by 3 times x minus 1 the square plus 4 by 9 times 1 upon x plus 2. And we have got it here because of this particular two functions, y and this 1 upon ax plus b, the nth derivative is this, 1 upon ax plus b the whole square, the nth derivative is this. We are going to get the values of, or you can say the nth derivative of this particular function as this. Very, very simple type of examples. We are going to go ahead with the successive differentiation. I have tried to give you a maximum insight of this kind of questions from this particular session. I hope you have understood it very well. Thank you. Happy learning.